The South African Mathematics Foundation, whose website is www.samf.ac.za, has been administering Olympiad competitions for several years for both junior and senior high school students. The junior competitions, called South African Mathematics Olympiad Junior, covers rounds 1 to 3, while the senior is also from rounds 1 to 3. This is one of several sessions which tries to unpack these various competitions. Today, we would in particular look at the 2025 Junior Round 3 competition, and we will try to attempt to solve those 15 problems which are in that paper. So without much further ado, let's just get straight into the relevant paper. Okay, sorry about that. So there it is. Okay, let's start straight away. Sorry for the delay. There were some problems that I had. We go into question 1. The first question gives you a kind of weighing situation here. And the idea is we've got lots of weights, and we are asked to order the weights from the lightest to the heaviest. Now you can see some of them are heavier. Like for instance, this line here is slanted, so this is heavier than that one. So let's look at that for the moment. So what we have here is that this weight here, the total weight here is, well, let's have a look at this one here. You can see that this is going down and that is going up. So therefore the C is heavier than A from here. And if you look at this entire weight, you will see that this whole thing is down. So the sum of all these weights, which is there are 2 A's and 2 B's and a C, 2 A's, 2 blues, 2 greens, and a C, that is heavier than what is on the other side of the scale. And what have we got here? You got 2A and you got 2 C's. You got 1 B and 2 C's. So that means that if you take off the 2 A's, you got 2B is greater than B, 2B minus B, to bring the B's to one side, is greater than 2C minus C. On the other side, simplifying it, the B is greater than C. So B is greater than C, and C is greater than A. So there it is. You have the lightest to the heaviest. Yeah, it's from the heaviest to the lightest. So you need to go from A less than C less than B, and they ask us to order the shapes from the lightest to the heaviest. Okay, so So that is how we do that problem. In all these sessions, I have the worked out problem as well. And in addition to my description of the solution, and I'll just expose that briefly. And you can see I've got the same kind of an answer. All right, let's get on to the next problem. We've got question 2. Question 2 says that you've got 2025, and that is the same as the square of 20 plus 25. Because this is 45 squared. So 45 squared is 20 plus 25. Okay, here, now the question is, how many numbers from 10 to 100, in other words, 2-digit numbers, inclusive? That means you can include 100, right? But the others are from 2-digit numbers. How many of them can be expressed in such a way? Now, what do you mean by that? It means that you want the, like for instance now, if I take 73, is that one of the numbers? Well, what we are saying here is that the number 73, where a number is equal to the square of a sum, of a particular sum of its digits parts. Okay, there are only 2 digits here, so the sum of the digits is 7 plus 3. And is this equal to 7 plus 3 all squared? Now this is 100, so that certainly is not so. So 73 is not one of the numbers. Okay, but you must, okay, by looking at this, you can see the numbers will have to be square numbers. Okay, so that helps a great deal to identify what the numbers are. They want to know how many such numbers are there. Then, if you start with 100, let's just eliminate the 100 case, and this, the 100 can be written as 10 squared plus 0 squared. Right? So this is one of them. Okay, so the 100 is one of them. Let's try to see the 2-digit numbers. So the question is, what are the 2-digit numbers that satisfy this condition? Okay, so we have to look at all the squares and see which ones work. Okay, so you've got the first square is 2-digit square is 3 squared, 4 squared. 3 squared is 9. 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and that's it. After that, you got 3 digits. Now here, now this is 1 plus 6 is 7, and 7 squared is 49. So that doesn't work. 2 plus 5 is 7. 7 squared is 49 again. 3 plus 6 is 9. 9 squared is 81. You want these to be this. You want these two to be the same. 4 plus 9 is 13. It's 169. It's too much. And 6 plus 4 is 10. 100. And 8 plus 1 is 9. 9 squared is 81. Ah, so this is the only one that works. All the others don't. So this is a tick, and that is a tick, and those are the only 2 numbers. So the answer is, the question is, how many numbers can be expressed in this way? And the answer is 2. All right, so the problem here is actually trying to understand what the question is, but it's important to notice, the thing to notice is that these numbers which we are looking for are square numbers, and that helps you a great deal to whittle it down to just a few numbers to test. and you get the answer. All right. So let's get on to the third question. Now, the third question says 4 of the big 5. Okay. Now, the big 5 are the animals in Kruger National Park or any game reserve, and they are identified as the rhino, a buffalo, and so on. Let's see. Sorry. So the big 5 are the elephant. Let's use the symbol E. For the elephant, R for the rhino, P for the buffalo, L for the lion, or 4 of the big 5. Okay, so just 4 of them. They are weighed 3 at a time. So if I take out the E, I'll have R plus B plus 11. I mean L. And if I take out the R, I have E plus B plus L, 3 at a time. So if you remove the B, you'll have E plus R plus L. If you remove the L, you have E plus R plus B. So you'll remove them one at a time. And they give you the 4 weights, but we don't know which ones are which here. So let's just call them X, Y, Z, and W. I can't say that this is one of these is 8490, the other one is 7090. I don't know which is which. Okay, we'll just call them that, where the set X, Y, Z, W, those 4 numbers are those 4 numbers which are given, which are 8490, 7090, 9200, and 3390. Right? Not in that order. Okay. Now the question here is, how much does the elephant weigh? Now this is quite tricky because you've got 4 unknowns and you've got 4 equations, so you should be able to solve. But you don't know what these numbers are, which is which. But you do know that the elephant is the heaviest. All right, so there is a nice, neat way of solving these kinds of things because there is a symmetry here. If you look on the left-hand side, you got 3 R's, R, R, R. So when I add the left-hand side, I got 3R plus, likewise, I got 3 B's, and I got 3 L's, L, 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 and I also have 3 E's. I got an E here, an E here, and E here, 3 E's. So that takes care of all the 12 symbols on this side, and that will be equal to X plus Y plus Z plus W. But so, in other words, regardless of where these actually are placed, we've got the sum of the whole 4. And this is R plus B plus L plus E. So the sum of those 4 is this thing divided by 3. So when you add those 4 numbers, I get the last number is 0. 9 plus 9 plus 9 is 27. Carry 2. 2 plus 4 is 6 plus 3 is 9. And 2 is 11. Then you get 1 plus 8, 9 plus 3 is 12. 1928. So, in other words, the 3 of that is this. And 3 goes exactly into this. 9390. Right? When you divide this by 3, Now, they want to know what is the weight of the elephant. All right? Now, the elephant weighs the highest. Okay, so the elephant will contribute the highest number to this sum. So the sum of the whole 4 is that. So you have to take out the lowest sum to get to the elephant. Right? So the elephant is 9390 minus the lowest possible sum of these 3. And the lowest possible sum of these 3 is 3390. That's an important observation, because if the elephant is going to be the heaviest, then the lowest, the other 3 will be the lowest possible sum of the other 3, and that's 3390. This works out to exactly 6,000, and it's kgs. So that is the weight of the elephant. All right, so let's get on. Just so you can see right at the end there, you got E is equal to 6,000 kgs as advertised. Let's get to the next problem. Question 4. Question 4 says, for which integer values of P is this an integer? All right. Now, let's try a couple. So say P equal to, say, 1. 1 plus 6 is 7. 1 minus 2 is minus 1. So that gives you minus 7. And that's an integer. So P equals 1 is a possible value. And let's try P equal to 2. For instance, P equals 2 is not possible. Make P equal to 4. So 4 plus 6 is 10 over 4 minus 2 is 2, so it's 10 over 2. And that's fine. That's also an integer. So P equals 4 is one of them. Like this now you can try out, but you don't know whether you're exhausting all the solutions. You might miss out a couple of solutions because you didn't try it. So there must be some way of actually solving this so you can get all the possible solutions. This kind of problem is quite common in Olympiad problems. And there's a way of solving this. And the way to do that is to actually divide P plus 6 over P minus 2. I'll try to see how many P minus 2 goes into this. You can do long division, but I find it easiest to put a P minus 2, the same thing here, and make a modification, right, to get to P plus 6. If I put P minus 2 at the top, I'll have to add 8, right, P minus 2. So the reason why we do this is that now we can see that this is equal to P minus 2 over P minus 2 plus 8 over P minus 2. And you want this to be an integer. All right, so 1 is already an integer. So in other words, this part here is an integer. Eight over P minus 2 is integer. What does it mean? It means that when you divide 8 by P minus 2, you're going to get a whole number. And that, if you think about that, that means that P minus 2 is going to be a factor of 8. That's the only way you can get 8 over P minus 2 to be a whole number. So now we know the factors of 8. That helps you a great deal. So P minus 2 is, I'll just put belongs to the set. It could be 1 or minus 1. Because 1, remember, this is an integer. So the positive and the negative values are accepted. So p minus 2 could be -1 because 8 divided by -1 is -8. That's an integer. And you could have, and the second factor of 8 is 2 and minus 2, 4 and minus 4, and 8 and minus 8. So these are the values of p minus 2, and therefore p is equal to, and I don't want to do this. You add 2 to each one of them, 2 plus 1, because p minus 2 equals 1. Put 2 to the other side, it will be 3. 2 minus 1 is 1, and so on. So you can find out that there are actually 8 possible solutions. We got 2 of them, right? 1 and 4, but there are 6 others which we didn't get, which we didn't even try. But that gives you all the possible solutions. That's a nice thing about this, because we are looking at all the possible factors of 8, and we know the whole lot. All right, so that tells you what the integer value of this p, or these are all integers, which will make that an integer. Okay, so let's go on to question 5. Now, question 5 says the first term in a sequence. So you got some sequence. The first term in the sequence is x. All right, so let's just put this down, x. Okay, this is the first term. The second term is y. And then you've got some funny looking thing here. What is this? Each subsequent term in the sequence is given by this equation here. And you got a subscript n for the term. So for instance, now if I want to work out the third term, I'll have to put n equals 2 here. So n equals 2 gives you t with a subscript 3 in it. And here you have t, n equals 2, so it's t2, and n equals 2, 2 minus 1 is 1, over t1. So in other words, the third term is the second term over the first term, right? So now we have a picture of this, because n minus 1, n, and n plus 1 are 3 consecutive numbers, right? And this is the largest. So each term, now t2, we already know this is t2, the second term, over the first term, so that's y over x. All right, so the third term is y over x. So the fourth term will be this over this. Now y over x divided by y, I'll do only this. Y over x divided by y, this over this, is actually, in other words, this time is 1 over y, right? Saying dividing, y is cancelled, and you have 1 over x. Okay, and if you keep doing this thing here, you get this over this is 1 over y, this over this is x over y. Right? When you're dividing two fractions, remember, you invert the fraction, so the 1 over x will become x over 1. And this over this is x. So you come back to x. So that means that all these numbers keep coming up. So the next one will be y, the next one will be y over x, and so on. So you can write down the entire sequence, because it starts repeating itself. Okay. Now let me just see which ones repeat themselves. This is t1 equals x. So this is the same as the seventh term, 1, 2, 3, 4, 5, 6, 7. So t1 is the same as the seventh term. And you can see the next one will be 7 is 6 more than this, t13. So t20, all these are all equal to x, right? Now, they say determine the product of the 2025th to the 2030th term inclusive. So I need to work out the 2025th term. Okay, now I know if I keep going on the sequence, I'll have 1, 7, 13. I know that these are all equal to x. So what is the general term here? This is 1 plus 6. This is 1 plus 12. So this is really 1 plus 6k, if you like. Right? K equals 1, k equals 0, k equals 1, k equals 2. You want this to be less than 2025, but you want to find the largest k. The reason for this is I want to know what happens right down the line when I'm getting to 2025. I want to see which is the closest one to this, which is equal to x. And if I know that one, then I'll be able to quickly work out what this is by looking at this the sequence here. Now, the closest one, all these numbers look like this. So so it'll be the largest value of k. That is where I got the largest, and that is 6k is less than 2024. Bring that to that side. So in other words, you want the largest multiple of 6. The largest multiple of 6, which is less than 2024. All right. The multiples of 6 have even terms. So let's try 2022. Right? Is this a multiple of 6? Well, it's even. And the sum of these is 6. So it's a multiple of 3 and it's a multiple of 2. And therefore, it is a multiple of 6. So this is a multiple of 6. So 6k is equal to this. So this number here, 1 plus 6k, is actually equal to 2023. And that number, t, that particular term, that's always equal to x. In particular, that there is equal to x. So if you want to find out what these terms are, let's write down all these terms here. You get x, and then you get y over x. I'm repeating that. 1 over x, 1 over y, x over y, and x. And we know that this is the 2023rd term, is this. This is the 2024th, 2025th, 2026th, 27th, 28th, 29th, and we want to go right up to 30. So the one after x is y. And this is 2030th term. So we've got the whole 6 terms from the 2025th, right? From here onwards. Those are the 6 terms, 25, 26, 27, 28, 29, 30. And we want to know what the product of all these are. Now, it's not difficult to find the product because y over x times x over y is 1. If you multiply these two, you get 1. Now 1 over x times x is also 1. And 1 over y times y is also 1. So if you divide this into 3 pairs, right, and each product is 1. So the answer is, if you multiply the whole lot, the answer to the question is 1. If you multiply all those, The answer is going to be 1. Okay, so let's go on to the next question. Let me just check to see. Okay, I show you. I don't know whether this is correct, but whatever it is, the answer here is 1. I may have got the wrong numbers here, but whatever. All right. Let's get on to the next problem. The next problem is, we go to problem number 6. Which of the following fractions is larger? Oh, you got 2 horrible looking fractions here. And you're not allowed to use a calculator. If you use a calculator, you'll be able to just write this in as a decimal, write this as a decimal, and there you have it. You can see what the larger number is. But now, how do you do this without a calculator? That's a challenge, you see. But you'll see that these 2 numbers are very, very close. So let's make this number here. Let's call it x over y. We'll use symbols. So this is x, this is equal to x, and the denominator is y. But this one here is 1 more than that, you see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7. So this is x plus 1. And this also is 1 more than this. So this is y plus 1. So the other fraction is x plus 1 over y plus 1. And the question is now, which is larger? Is this or this? Okay, so the way to decide that is subtract the 2 of them and see whether the answer is positive. If the answer is positive, then you can see which is larger. So I'm going to subtract x over y minus x plus 1 over y plus 1. See, it's much easier to work with symbols. Suppose we worked with these monsters here. That would be horrible. So here you can simplify this. The common denominator is y into y plus 1. Y goes into y plus 1. So you get x into y plus 1 minus, and then you got x plus 1 times y. Right? So the common denominator is y plus 1. It goes into this y times. You must multiply it by the numerator. And let's continue to simplify. You got xy plus x minus yx minus y over y into y plus 1. And xy minus yx disappear, and you got x minus y over y into y plus 1. Now, why am I doing this? I want to find out whether this number is positive or negative. If it's positive, then I can say that this is greater than that. If it's negative, then I have to say I'm taking a larger number from a smaller number. So this would have been larger. So I want to know which is larger. Now you got x minus y. What is x? X is this. And this is y. And x minus y is clearly negative because this is smaller than this. So that is negative because x minus y, and of course y and y plus 1 are both positive. So it means that the larger is, you got x minus 1 is negative, so x over y must be less than x plus 1 over y plus 1. So this is the larger one, right? In other words, the larger of these 2 fractions is the one on the right-hand side, 1, 2, 3, 4, 5, 7. 2, 3, 4, 5, 6, 9. And this is larger. All right. So that's a very nice example where if you use symbols, you can work this thing out very quickly. But if you used these monstrous numbers, you would have landed up with a headache. You have to do long multiplication and so on. And that is really not something that you want to do. Okay, so let's just see whether this one ending with 7 and 6 is the larger one. Oh, okay, so it's exactly the same as what I had done earlier on. So let's get on to the next problem. We go to question 7. Question 7, there's usually an area problem. You can see there's some kind of an area problem here. So what's going on here? In the diagram below, 3 circles. I can see 2 circles, each with radius 1. So this has also got a radius 1 in all cases. So this circle is not drawn completely. See, what I've done here is I've drawn that circle in full. So 2 of the circles touch each other, as you can see, and this is a sort of common tangent. It's a tangent to both circles. They touch, right? And the third one passes through the point where the two. So the third one goes through this. So can you see I've actually drawn this thing, so the third circle goes through this. Um, Now, the question is, find the area of the shaded region. Now, how do you do that? You have to see how you can break this thing up into parts which are those areas we know, but it looks like a very, very strange shape. We can't even break it up into circles or triangles or whatever. We'll have to do something else. So I want to point out that when you join these two centers, it would be perpendicular to this common tangent. A radius drawn to a tangent is always 90 degrees. See, it's a very important fact. When you draw a radius and you have a tangent and you join this center to where the tangent touches, that radius there is perpendicular to the tangent. So you'll have that this is 90 and that is 90. So all these three are in the same straight line because this angle here is 180 degrees. Now, there is a center to this circle. The center is shown here somewhere. And so what I've done here is, I'm going to do it here. There's a center here. So let's just join the center to that, like that. Now, this is a radius. This point here is the center of the circle. Now, this is the radius of the blue circle, and the radius is 1. This here is the radius of this white circle. That radius is also 1. This radius here is 1. Okay? And now even on this side, you can do the same thing. If you join this to that, join that to that, and again you'll have 1, 1. All these are 1. So what you have here is a rectangle. See, and so this part here is also 1 here, from here to here. Oh yes, this part is 1 because this is the center of the circle and this is 1. I really needn't have drawn this other part. So what happens here is, I just want to, this is rather complicated, the diagram there, but we will need it. Let me take it out from here. Now, what happens here is that I see that I've got, that is 1 because it's given that the center passes through this point of contact. So you have a figure here with all the sides are equal. So it's either a rhombus or a square, but this is 90 degrees, so it's a square. Okay? So you have a square here. Right? Now that's what you got here. You see this part here? This part here is a square. Likewise, this part here is a square. Now, what I've done here is I've drawn the full circles because I want to find this blue area. And so what I've done is to find the blue area, this part here, this corner part, I can actually do that. If I join these two, then I've got an interesting situation here. This blue part here, when you add it to this white part, then you get a triangle. So in this diagram here, you will see that I'm calling this part here. Let's call that X, call that Y, and that's the white part here. So you got that X plus Y is actually equal to the quarter circle. This is X. These two whites give you a quarter circle. And the circle, the area of the circle is pi r squared. So the area of all these squared circles is pi times 1 squared, which is pi. So the area of X plus Y is pi over 4. And Y itself, I know, because Y is a right angle triangle. It's half a square, and it's half base times height. So it's half base times height, 1 times 1, and there is a half. So Y is half, and X plus Y we know. So therefore, X is pi over 4 minus Y, which is pi over 4 minus 1 over 2. Right, so I've got X. So let's just hold on with that. Why do I need this X? You see, in this diagram here, watch. When I draw the full circle, the blue part, I wasn't able to shade the blue part in using my computer. But this is the blue part in this diagram. Let's just shade that. And all this stuff here. Okay, that's the blue part, right? Now, you'll notice that this X here is actually equal to this other, these two are the same. When I'm saying these two are the same, I'm going to just color that. So I'll color that blue. So this is X, and there is also X by symmetry. Okay, so This entire area here is 2x. That's why I got 2x on this side. Fine. Now you can see where I'm getting to, because what we have here is now you can see the black plus the two blues is the area of the circle. So you got the black. Let's just get this color back. So you got the black plus two blues equals the area of the circle of radius 1, and that's pi, the area of the full circle. So we are looking for the black. So the black is pi minus two blues, but the blue is 2x, right? We saw this. So therefore, this is pi minus 4x. We already calculated x. So the black part, shaded, let's call it, this is what we're looking for, the shaded region, is the black part, is equal to pi minus 4x, and x is pi over 4 minus a half. I calculated x earlier on. Okay, and now when you simplify this, you get pi minus 4 times this. So 4 times this is pi, plus 4 halves is 2, and pi cancel, and the answer is 2. Very nice answer for a rather odd shape. And so the shape there is actually 2. No pi or anything like that. It's a nice round number. Okay, so that takes care of question 7. And now I want to go on to question 8, but I just want to show you this, and you can see I've written out the solution here again in case you didn't understand this. And I don't know whether I did it the same way. I may have or may not have, but usually it is. So let's get on to the next problem. Okay, now question 8 says a rectangular prism with distinct edges has distinct edges x, y, and z. So there's your prism. It looks like a trough or a box. Looks like an empty box actually. And the sides are x, y, and z. So let's just put them like that. So one is x, one is y, length, breadth, and the height. Okay, the sum of all the lengths of all the 12 edges. Now, other 12 edges you got, you got these front and the back. That makes 4. And then you got these 2, another 4, and then the vertical ones are 4. 4 vertical ones you can see. So there are 12 altogether. But it is actually 14. So let's work out all the sum of all the edges in terms of x, y, and z. Now the x is repeated 4 times. You can see x, 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 that, and that. Likewise, the y is repeated 4 times, and the z is repeated. And that gives you the 12 edges, and it is given that is 13 over 4. All right, so it's 4x plus 4y plus 4z. No, it's 14. Sorry, I got the wrong one. This should be 14. Okay, we can say divide by 2, you get 2x plus 2y plus 2z. Is 7 then. Okay, I don't want to bring in the fractions, just leave it like that. Now what else? We've used this fact here. And the sum of the areas of the 6 spaces. Now what are the areas? like if I look at the area here, the face that I'm looking at here, that's YZ. Now, this area is repeated on that side. So you've got those two, gives you 2YZ, the side one plus the side one. And the bottom one is XY. You can see X here and Y here, but that's also the same as the top. So that's 2XY. So that takes care of 4 of the sides, or 4 of the faces, right? And then the only one that is missing is the front and the back. So this is Z here. So the front is XZ and the back, so you get 2XZ. And we know that that is 13/4. All right, so you got 2 equations involving these things. So what's the question then? What is the length of the interior diagonal AG? Okay, so I need to work out the diagonal. This red line is going from one corner to the other corner. Now, this kind of thing occurs quite often in the Olympiad problems. And the way to do this is to simply, you go up there and you come down here. Now, remember, this is a box. So this is a vertical. It's vertical to the floor. I like to think of this bottom base here as floor. And then what you can do is you can join those two, right? And the red line, which we are looking for, is actually the hypotenuse of a right angle triangle. Say AG squared, AG, and here the right angle, this is perpendicular to the floor. So this angle here is 90 degrees. That might be a little bit difficult to understand, but it's vertical. This is a box, you see, it's a prism. So you've got this, all these lines. This is also perpendicular to this. You think of the corner of a room and you'll know what I'm talking about. So this is Z here. So this is AC squared. The other side is AC squared plus Z squared. But now if you look at AC squared is the hypotenuse of a right angle triangle on the floor. Right? This is a rectangular prism. So AC is also the diagonal of a right angle triangle, and AC squared is X squared plus Y squared. By Pythagoras applied to the triangle ABC, AC squared is AB squared plus BC squared, because this angle is 90 degrees. So in other words, we need to calculate that. So I know this, I know that. How do I calculate this? Okay, so to that end, you have to know something. It's X plus Y plus Z all squared, right? Now all Olympiad students should know the formula for the square of a triple. You know the square of a binomial, right? Which is the square of a sum of 2, but the square of a sum of 3, this is the formula: X squared plus Y squared plus Z squared. And then you have 2 times all the possible products of 2. 2xy plus 2yz plus 2xz. Okay, so that's quite useful because this is your unknown. And x plus y plus z, I said I'm not going to work out x plus y plus z, but I have to do it now because, so 2x plus 2y plus 2z is 7. So x plus y plus z is 7/2. So this here is 7/2 all squared equals this unknown, which is AG squared plus. Now 2xy, this thing here we already worked out, is 13 over 4. Okay, so now you've got just as one unknown, namely AG squared. That is 49 over 4 minus 13 over 4, bring it to the other side, and that's 36 over 4, which gives you 9. So AG itself, lovely number, it's got a square root. AG squared is 9, so AG is equal to 3. So rather complicated looking problem, and the answer that AG is actually a nice whole number, namely 3. All right, so let's just check to see whether we had the same thing. Oh, okay, now it's very much less working involved here, it seems, but you can check that out, and that will take care of problem number 8. This is problem number 8. Okay. Okay, so that takes care of problem number 8.